Lesson 9.2, Properties of Reflections. Lesson 9.2, Properties of Reflections. Example 1, Graphing Reflections. To reflect a figure across a line of reflection, reflect each of its vertices, then connect the vertices to form the image. Remember that each point and its image are the same distance from the line of reflection.
All right, let's take a look at another transformation. This one is a reflection. So the question is to graph the reflection of the triangle XYZ across the y-axis. So what does that mean? It means that I want us to think about what this object looked like if you were to kind of move it over the y-axis, like a reflection. In fact, imagine a mirror right there. In fact, you don't have to imagine a mirror. Oh, look at me. Okay, anyway, it's the story. But if you imagine the mirror right here, okay, and I'll just tilt it so you can see it now because you don't have a good view. What you'll see is how it would look. And that's what it would look like. You see how it's a reflection? So it really, when you think of reflection, think mirror. And you really got it. And reflection across the y-axis means the mirror is going to be right on the y-axis, and then you see where it is. Okay, I don't know. You think which is nicer, that look, or this look? Okay, anyway, separate question. All right, so how can you visualize this? Well, you could actually imagine doing it for real. Think of putting a movable triangle here on a sheet of paper or plastic, and imagine the binding of the book be right on the y-axis, and you're literally going to just turn the page. So turn the page, that's the reflection. Turn the page, that's the mirror reflection, and there it is. So how do you find that? Well, if you think about it, the y values aren't going to change at all. The height of this point x is not going to change when I look at its corresponding point, which I'm going to call, of course, x prime. And the height of the z and the y aren't changing as well. But what changes with respect to the x? Well, in fact, notice that by reflecting it, all we're going to do is have a sign flip. The sign will change, which basically means don't change the magnitude of the number, just change its sign. And so that's how we change the x values. That's how we change the x values. And let me show you what I mean. Oh, by the way, did you fall for the thing that I think you might have fallen for? Is that really y prime? I don't think so. Because when we reflect the page, that's the z. It's way over there. That's the z. Now, why would you let me make that mistake? This should be z. Because this corresponds to the z. And when you flip this, this corresponds to the y. This is a classic mistake, which I did deliberately to see if you were following. So there's the y prime, there's the z prime, and I'm sticking with the x prime. Okay, but back to what I was saying. So the heights don't change, but the x values have to change sign, which means multiply by -1. That's what it means. So multiply by -1. So that's the rule. So if I come back to the actual rule here, I can find the coordinates for x prime by doing what? Just by multiplying the x value by -1 and do nothing to the y value. And so what's this? Well, then x prime is going to be -1 times -3 is going to be 3, and then comma 4. Let's check it. 1, 2, 3, 1, 2, 3, 4. What about y prime? Same rule again. I multiply the x by -1, do nothing with respect to the y value, so y prime is going to be 1, 0. Now check this out. 1, 0, where is it? That's going to be 1, 0 is right there. So if I wouldn't have caught that mistake a moment ago, I would have caught it right now. Because the rule tells me that that has to be a y prime, and of course we see that is the reflection. So even if you make a mistake sometimes, you might catch your mistake even a little bit later down the road. So that's awesome. So congratulations to you. And z prime, same thing. -1 times the -4, and 0 we do nothing with, and that's going to be a z prime of 4, 0, which knows exactly is, again, the z prime. So there you have it. We've actually seen a transformation that's of the reflection type, where you actually have to be reflective.
All right, let's take a quick gander at the lesson tutorial, just to be sure we have down the basic concepts. Graphing reflections on a coordinate plane. Graph the reflection of triangle XYZ across the y-axis. So we're going to reflect triangle XYZ across the y-axis. And our general rule is to multiply the x-coordinate by -1. So for each of the coordinates here, we're going to multiply the x-coordinate by -1, and then that will give us our new position. Okay, so let's start with x. Currently, x is at a -3 and 4. -3 and 4. So our rule says multiply the x value by a -1. So a -1 times a -3 is a +3. So see how it becomes 3, 4? -3, 4 was the beginning, and 3, 4 is the end. For y, we got a -1, 0. If we multiply the x-coordinate by a -1, we end up with a +1 and then 0. For z, we're going to end up with a -4 times a -1. That's going to give us a +4 and then 0. So once again, you multiply each x value by a -1 when you are reflecting across the y-axis. Okay, now notice the rule for when you reflect across the x-axis. That is, if you were to take this here and reflect this way. Notice the rule, multiply each y-coordinate by a -1. So now your x value stays the same, but your y value is being multiplied by a -1.